back Algebra 1. We're in lesson 65 today, and we are going to talk about, back to that page, addition of radical expressions. So in lesson 18, we found that like terms could be added together by adding the coefficients. So all that means is if we had 3x plus 2x, we could see that the variables were the same. Those factors were going to have the same value, so it made it easy for us to say that that would equal 5x. Well, now we're going to do the same thing with radical expressions. So that just means that if I have 3 times the square root of 2 plus 2 times the square root of 2, that I can add the numbers in front, the factors in front of the square root, and get 5 times the square root of 2. That's all that means. It also means if I have, let's say I had 3x plus 2y plus 4x, then I wouldn't be able to add the 2y in there because it's different, right? So my answer would be 7x plus 2y. The same thing is true for the radicals. If I have 3 times the square root of 2 plus 2 times the square root of 3 plus 4 times the square root of 2, what I end up with would be 7 times the square root of 2 plus 2 times the square root of 3. Why? Because there are no other terms that have the variable square root of 3. Because that's what we're treating it like. We're treating it like its own unique variable. And the number inside of this little square root symbol, that is what determines whether or not these are like terms. So this is the square root of 2 as a variable, and this is the square root of 2 as a variable. So these two are like terms, so we can add them together. That's all this is. That's the lesson for addition of radicals. So let's do a few practice problems doing that. So let's do 65.1, and that just says to add these terms together. All right, so I hope that you are writing these down as I'm writing them down, because that's what you're supposed to be doing. So let's solve this now. So we have 4, and we have a square root of 2, 5 square root of 2, 12 square root of 2. These are all the same variable. So these are all like terms. That means we can combine the whole numbers in front of them, easy peasy. So 4 minus 5 is -1. A -1 and a positive 12 is going to be 11 times the square root of 2. And that is the answer for 65.1. All right, let's do 65.2. And we are supposed to add these. And this is what we are supposed to add. Write it down as I write it down. That way you can solve it as soon as I get through writing. So what do we see here? Why don't you go ahead and try to solve this one, and then check back for the answer in just a moment. I'm going to pause, so I want you to pause. All right, if you got -2 times the square root of 3 plus 3 times the square root of 5, that's correct. If you also got, or if you got instead, 3 times the square root of 5 minus 2 times the square root of 3, if you just reversed the numbers, then that's right too. A lot of times people like to put the negatives on the inside, and that's perfectly okay. 65.3, let's add these. All right, so let's see what we got. I'm going to let you guys do this one also. So pause the video, solve this, and come back and check your answer. All right, so if you got -5 times the square root of 2 plus 13 times the square root of 3, then you got the correct answer. If you also got 13 times the square root of 3 minus 5 times the square root of 2, that is correct as well. So you know how whenever I tell you to write the answer in your in Jupyter Ed, I say write the variables in alphabetic order, and then if everybody writes it in the same order, the system is more likely to mark it correct. We're going to do the same thing with the radicals, but instead of alphabetic order, we're going to put them in numeric order. So what that means is that this is the one that will be typed into the system because it's in numeric order, right? The 2 comes before the 3. So if you if you do that, then you're going to be more likely to get it marked correct. That being said, I'm always going to check your wrong answers and make sure that they're actually wrong and that the system didn't give you a false negative. So if you did write this, I would still catch it and I would mark it right. But if you write this, the system will catch it and I don't have to mark it or check it again. It'll automatically do it for me. So try to do it like this if you can. If you forget, you're automatically forgiven. It just means it might take me longer to get your grade put in the system. So let's do the last one, 65.4. Write these down as I write. 4 times the square root of 3 minus 2 times the square root of 2 plus 6 times the square root of 5. All right, if you're looking at that and you're thinking, I don't know if you can do anything. I don't know how to do that. You do know how to do that, and the answer is that you can't do anything to it. All of these radicals are different numbers. So these are all 3 different terms. We don't have any like terms. So you can't add these at all. The answer would be exactly what you see here because we don't have numbers or terms that we can combine. All right, let's move on. Let's talk about weighted averages. A weighted average is something that your teacher uses, primarily me, for your scores. Like, for instance, this class is set up so that homework is worth 30% of your score. Your lessons are worth 30% of your final score. And your tests and quizzes are worth 40% of your score. Okay? So what that means is if you get a grade, we reduce percent to the decimal form, it'd be 0.3. And we would multiply it times whatever your average of your homework scores are. Let's say you made 100% on your homework, right? So that would be times 100. So 0.3 times 100 would equal 30. Okay? If we did this to your lessons, we would say 0.3 because that's 30% in decimal form. And that would be times your average lesson grade. Well, if you made 100 there, then that would equal 30, right? Now your tests and quizzes, it's 40%, so that would be 0.4, that's 40% in decimal form. And if you made 100% on all your tests and quizzes, 0.4 times 100 is 40. And then we would add those 3 grades up and you would have gotten a 100, which 100%, 100%, 100%, that is 100. So why, Miss Tracy, do we go through this trouble? Well, let's just say and assume, let's say you don't make 100% on everything. If you make 100% on everything, of course your grade's going to be 100%. That's just the way the math works. But let's say, for some reason, you don't do your lessons, right? You get a big fat 0 on your lessons. You did your homework, and let's say you made a 90 on your homework, which is great. And on your quizzes and tests, let's say you made an 85, right? So you're thinking, oh, I did pretty good. I made 90% on my homework, and I made 85% on my tests and quizzes. I should have a high B, right? Wrong. Because the way it works is this. 30 times 0.9, it would be, or 90 times 0.3 would be 27. 30% of 0 is going to be 0. And I need a calculator for the last one. 85 times 0.4 is going to give you 34. So your final score would end up being 61. So you would have a low D minus, my friends. That is why you have to, that's why we do this. You have got to apply yourself equally. Okay, now if I were to average these out, just straightforward, let's see what that would be. 90 plus 0 plus 85 equals, divided by 3 grades, it'd be even lower. So if I just did a straight average, you'd have an F. That's no good either. So it's very important to do all your lessons, to do all your homework, and to do all your tests and quizzes, because it's going to impact your grade. But also note that because this is 0.4, this is worth more than the others. Yes, the homework and the lessons are the bulk of your score. That's 60% of your score. But the other 40%, those tests and quizzes, we only have about 13 or 14 of those per semester. We have 60 lessons and we have 16 homeworks. So the homework, 16 lessons of homework is, each one of those is worth way more than the lesson scores. And your quizzes are worth way more than the homework scores. That's why weighting is so important, because a teacher feels like some things are more important grades than others. Let me give you an example of that. I'm going to pause and type this in here for you because my handwriting is atrocious. All right, so let's talk about Susan for a minute and her teacher. Susan's scores improved with each test. Her first semester test was 60. Her second semester test was 71, and her final exam was 91. The teacher did not think that just averaging the 3 grades together would be fair. And if she had done that, 60 plus 71 plus 91, and she had 1, 2, 3 grades, that average would have been 222, would have been the sum in the numerator, divided by 3. She would have had an average of 74. But wait, her final exam, she made a 91. That should count for more than that. Her teacher agreed. Her teacher thought, this first semester should be worth the least because it was only the first semester of information. And then she thought, well, the second semester exam, that material in the second semester was actually harder than what was in the first semester. So it should be worth twice as much as what's in the first semester, right? So she said, let's multiply that by 2. Make that worth twice as much. And then she said, but the final exam reached all the way back to the beginning of the school year, so it should be worth more than both of these put together. So she said, let's do 4 times 91. Let's make it worth 4 times as much as the first one, because it went all the way back and it tested all her knowledge. And then she said, we're going to add these together. So 1 times this plus 2 times this plus 4 times this. So her total, when we did the multiplication here, we did 60 plus 2 times 71 plus 4 times 91. That would be 566 all over 7. When we did the division here, she made an 81. It was like 80.86, but we rounded it up. That's a much better score than this. And I think, just like Susan's teacher, that this better reflects her mastery of the material, because she did so much better on each test. She got better and better. And so her score should be an encouragement, and it should reflect how good she's actually doing. Now, yes, we still have to include that first low score, because maybe she didn't study. Maybe she didn't take it seriously. Maybe she watched movies the night before instead of studying for her test. We don't know, but what we do know is she really put in some good effort on that final, and that final also covered the material that was here and here. So she should get, a little bit of extra on that. And so that's what the teacher did. By weighting these scores, by giving them extra value, it increased her final average. All right, let's try an actual example problem. Let's look at 65.5. All right, I'm going to read this to you, and then we're going to write down the facts. That way I don't have to type it, and you don't have to read my terrible handwriting. So Jim's scores were 60, 70, 80, and 90, okay? What is the weighted average of his scores if the tests were weighted 1, 2, 4, and 6 in this order? So we would say 1 times 60 plus 2 times 70 plus 4 times 80 plus 6 times 90. And then we have 1 plus 2 plus 4 plus 6. So that's going to be 1060 when we do the multiplication. And this is going to be 13. So 1060 divided by 13 is going to equal 82. Because when you round up the decimal point, that's what you get. Now, if we had just averaged these all out together, if we had said 60 plus 70 plus 80 plus 90, and that would be 1, 2, 3, 4, let's see what we would have gotten. So that would be 60 plus 70 plus 80 plus 90 divided by 4. Oh, I didn't do something right. 60 plus 70 plus 80 plus 90 divided by 4. That would have been 75. Weighting the score is in the student's favor. That is why we weight those scores, to better reflect what the effort in each category is worth, and also to give you your best average possible. That's why we do that. That's why weighting is so important. And many times teachers will kind of play around with the weighting from one semester to the other to see if it's more accurate, if it's better reflective of their students' efforts. Especially if they know they have students who try really, really hard and put in the extra effort, but the average just doesn't show it. Sometimes a teacher will try to give you credit for the effort. Then, they know you're doing their best. But they still need to be fair to those other students who are performing and doing a good job. All right, so again, weighting is just how many times this number is going to be added into the average. And then what you divide by is the total number of items that were averaged together. And then that gives you your final average. Let's do another one. So this one uses the percentage method, which is what the Jupyter system uses. And this one says, in a graduate level course Smith R. was taking, each of 3 tests were weighted. So we had 3 tests, and they were each worth 20% of his final score. And then he had a final paper that was worth 40%. So on each of the tests, he scored a 60 on one, a 70 on another, and an 80 on another. And on his final paper, he made a 60. So we take this and we turn this into the decimal form of 20%, which is 0.2. And if you don't remember how to get there, 20 over 100, that's 20%, right? It goes from 20% to 20 out of 100 because that's what percent means. It means out of 100. So 20 out of 100. And you can easily do that on the calculator, or 20 divided by 100 is 0.2, or you can count the number of zeros and just move your decimal that many places, okay? It's the same thing. It's the same method. So 0.2 times each of these, 60 plus 0.2 times 70. And the benefit of using percentages and decimal points is your division is already done for you. It's done ahead of time. And I'll show you what I mean in just a moment. 0.2 is 80. All right, and then you have the final score. 40% is 0.4 times 60. So when we do all of that math, we get 0.2. We're still going to do the same thing that we do. We're going to add all of these up. 0.2 plus 0.4. When we add all of these up, we get 1. And that is what I mean by the division is done for you. When you multiply times the decimal and all of these decimals added together equals 1, whatever the grade is that you finish up with here, that's the total. That's why we use the percentage method. It's because then we don't have to add everything up and then divide it. It's done for us when we divide it into a decimal in the first place. So 66, would be his final score given this weight and these grades. All right, and that is all we have for weighted averages for lesson 65. I will see you all in lesson 66.